Hi, I'm Joe, and you're watching In Joke, and I'm reporting to you from my new digs. But more importantly, for the past few weeks, you may have noticed I've been posting a lot more shorts with some animation and modeling experiments that I've been working on. Well, that's all been a part of this whole new thing that I'm trying to do called stalling. Since the end of last year, I have been working on a project that will answer the question I announced in my prior project log video. The question that 3D modelers have been asking since the advent of Blender. And that question is coming right after this shameless self-promotion. If you're a programmer or RPG enthusiast, and you've liked some of the work on my channel, maybe you've liked it so much that you want to adorn yourself in it, or maybe even just spread it around your workspace or environment. I don't know where you live. But if you do want to do such things, then check out the Red Jacket, Redbubble, and TeePublic stores, where you can find programmer and RPG-based accoutrements and apparel that feature works that were a result of projects featured on this channel. Yet again, that's the Red Jacket, Redbubble, and TeePublic stores. Now, on to the video. So, the biggest question in 3D modeling. What is it? If you saw the title of this video, you may have already guessed it. But that question is, can you turn Blender into a QR code generator? And if you're curious about the answer, keep watching. Let's find out. I don't think I mentioned a lot, but I am a trained programmer. And one of the things that I find most interesting about computer science and programming are file structures. So I've always wanted to learn how things such as barcodes and QR codes work, since that's just another way of encrypting data, which is essentially what a file structure is. So I was inspired to start this project after watching a video on QR codes by the channel Veritasium. The video describes the way QR codes are created, how they work, and most importantly, how they're generated. You know, the data structure and all that. After that, I started wondering, is it possible to generate a QR code in Blender? But before I try making QR codes in Blender, I need to dig deeper into how QR codes are made, specifically how their data structure is laid out, because while Veritasium's video broadly went over it, their video isn't really a comprehensive guide to making QR codes. So I searched on Google for how to make a QR code. And after a bunch of online QR code generators, I finally stumbled upon Thonky.com, which is a video game guides website, apparently. But they had a guide on QR codes. Faced with the daunting mass of text and my ever so inconvenient dyslexia, minute as it may be, I started to hesitate, wondering if it was going to be worth it reading through this whole site, then maybe later finding out that the information was incomprehensible or overall incorrect. Even given that, I started to slowly read through the site over the course of a few days, maybe weeks, extracting small bits of information. It was during this period of time, towards the end of last year, 2024, I saw this video. I built a QR code with redstone to find out how it works, by Matt Batwings. The video pops into my feed. I watched it, and it gave me some confidence. Matt Batwings was not only inspired by the same video that inspired me to make this project, he also stumbled upon the same tutorial website I did, Thonky's. Knowing this, I could be rest assured that I was on the right track. So, knowing this, I jumped into the first step, which was figuring out what version of QR code I wanted to make. There are multiple versions of QR codes, mostly based off the size of the message that needs to be stored within them. Each QR code can carry a message of a specific maximum length, the information of which you can find on Thonki's tutorial website on this page. My goal is to store the link to my channel within the QR code, so I picked a version 3 QR code with error correction level M. More on that later, or you can go read the Thonki tutorial, or watch Veritasium's video, or Matt Batwing's video. A version 3 QR code is 29 by 29 units in area, and can store a maximum of 42 characters, not including the error corrections. My channel link is only 32 characters in length, so 42 will be just adequate. Actually, more than adequate, but yeah. After reading the first few bits of the Thonki tutorial and watching Veritasium's video over and over and over again, I thought, oh, this will be easy. All I have to do is find a modular way to print these 8-bit blocks onto the texture. Oh, but before we move on, a quick tutorial on creating tiled or section textures in Blender. When working on a texture, you're working in UV space where your coordinate values are clamped. And as you 3D modelers and programmers and I guess mathematicians know, that means your values are between 0 and 1 inclusively. So how do we get a 1 by 1 space to represent a 29 by 29 space? Simple. We scale it or multiply our coordinate values by the size of our QR code, 29. And that looks a little something like this. However, I later found out that I kind of shot myself in the foot doing that. QR codes are supposed to have a space called the quiet zone, meaning our scalar needed to be more than 29. It is recommended that the quiet zone be 4 units in size, so following that recommendation, I added 4 units to the scalar, making it 33. Then after that, all that was left was for me to make a node that would output a specific color within a specific range within our space. And so the bit drawer was born, followed by its children. So with that out of the way, where was I? Oh yeah, I thought this was gonna be easy. All I had to do was draw these 8-bit blocks, right? Wrong! Absolutely wrong. Because after our bits snake like this, we hit the alignment square, and things go all jabberwocky. I mean, look at this thing. What is it? So now I need to figure out where the rest of the bits go, and while I could draw out the map by hand, like I had to do later, multiple times, because I kept getting it wrong, before I did that, I searched for a QR code version 3 map and found this website. Which, by the way, good tutorial, just not as comprehensive as Thonki's. However, it did show all the unique shapes of the 8-bit characters within a version 3 QR code. So TLDR, through a series of misconceptions where I thought they were wrong because they didn't start with the 4-bit mode identifier at the bottom right of the QR code and didn't go through the timing strips, even though later on I figured out I was wrong about that. You were not supposed to go through the timing strips. This was supposed to be, long story short. It turns out they were right after my message bits. Because I separated the 4-bit QR code mode identifier, my message strips looked different than their unique shapes. However, after adding the Terminator bits to my message bits, the unique shapes the 8-bit characters took looked like the shapes found in this article. So kudos to them. So after this long-winded process, all I had to do was make all these unique shapes, which resulted in this. Hey, quick thing, I just realized while editing that I didn't mention the nodes created to display the 8-bit blocks take in a ASCII decimal representation of specific characters. Using this value then decides which bits to flip. By the way, all the nodes have these inputs. They change based on where the character is within the QR code. And also note, nodes such as the 4-bit block only have the binary inputs, not the ASCII decimal value. Hopefully that gives you a bit more clarity on what's happening here. Now back to the video. Though basically all the subsequent nodes were various combinations of the 1, 2, and 4-bit row, column, and box nodes, or as I called them previously, the children. Now, after all that, we should be close to the end. All that's left was to arrange all these nodes in the appropriate shape to form a QR code. Though, this process was so intense that my computer took minutes to render any changes I made. And I'm not talking about rendering out the final QR code, I'm talking about rendering my computer display. I could literally get up, get some milk and cookies, come back just to see the end of it rendering out. And even with a CPU bottleneck, this is just insane. What project did I sign up for? And after arranging all these nodes, I was still not done. I still had to enter the ASCII decimal representation of my message, my channel URL. I did, however, write a PHP script for that, though I did have to check it by hand because I couldn't be 100% certain it was correct. But in the end, it was worth it, right?
Wrong! You're wrong!
Apparently, all this was too much for my GPU and Blender, so they decided to quit. There were just too many nodes. Do you know how confusing it is to see a missing texture when you're looking directly at the texture? At this point, this task seemed insurmountable. If my computer is simply too feeble to have Blender generate a QR code, then how am I supposed to prove it works? Am I to admit defeat and simply say, the question does not have an answer? My thesis could not be proven? Well, I say nay. To paraphrase the late, great Technoblade, the sunk cost fallacy simply will not allow me to quit. So what's the solution? Well, I can render my message bits separately, and I can render my error code separately. So all I have to do is figure out how to merge them. And you can bake textures out to PNG in cycles, right? Now we're cooking with... So apparently, cycles renders less nodes than Eevee. But the sunk cost fallacy simply would not allow me to quit. If I can't bake it in cycles, I can photograph it in Eevee, where I know it renders. I essentially had to place the field of view for my camera right up against the QR code. But it was able to render. And with a bit of finagling, I was able to finally render out a QR code. Now all that was left was to scan it.
Why are we still here? Just to suffer.
At this point, I had no idea what was wrong. But the sunk cost fallacy would simply not allow me to quit. So I kicked my programming brain into overdrive and started debugging from the ground up. It took 2 weeks. I reread Thonkies. I checked every node. I checked every input value. At some point, I drew the message bits and error code bits by hand, printed it out, and checked it against the QR code. Then, well, actually that was a good idea because there were a few bits that were wrong. But even after I fixed that, it still didn't scan. I was at my wit's end. It was only at the end of those 2 weeks that I stumbled upon this. A Reed-Solomon calculator. So just to check that it was working, I put in the decimal ASCII values of the message on Thonkeys. It worked. Then I put my message, decimal ASCII representation, into the calculator. And it was different from the one I got. You see, I created a PHP script to generate my error correction bits using the guide on Thonkeys tutorial. And when I tested it out against the message on Thonkeys, it was correct. I had no idea that I had stepped into a programmer's worst nightmare. When your code works, sometimes. I mean, this is why they have code testers and test scripts to test against tens to dozens to hundreds of cases. But I didn't have that. I just had this one case. So after finding the calculator, I tested it against my code using random numbers and different generator polynomials. You can read more on that in Thonkeys or Veritasium's video or Matt Badwing's video, but a quick rundown. You divide the polynomial representation of your message against a generated polynomial from Reed-Solomon-Gallusfield arithmetic. Yet again, I would really just check these sources for more information. But then after you divide them against each other, you get your error correction bits. So even after testing random numbers, all I could determine was my code worked. Sometimes. At this point, even though my pride as a programmer was hurt, and I'll eventually figure out what's wrong with my code, I decided to use the error correction values from the Reed-Solomon calculator, and finally, it worked. So to answer the question that all 3D modelers have asked since the dawn of Blender, can you turn Blender into a QR code generator? TLDR? Yes. Yes, you can. And on a side note, I also made all the QR code masks dealing with all the weird, minute calculation errors that I needed to fix. All that will be in the documentation, which is hopefully linked down below. If not, it will be there eventually. Thanks for watching. I think this is my first scripted video, and if you liked it, please leave a comment below sharing what you liked about the style, or subscribe and hit that notification bell so you can catch my next video. Thank you to Veritasium for inspiring this video, and Matt Batwings for showing me I was on the right track. It seems that now I'm part of this weird short string of videos finding ways to make QR codes. But either way, joke out!